Everybody, I'm going to walk you through the practice test. Hopefully I get everything correct. If I make a mistake, you're going to see it. Hopefully I see it and I correct myself. In other words, this is unedited. You get what you get. So if I do make a mistake and I don't find it, I'm sure you will let me know in class, right? Or you will email me, okay? But anyway, we're going to get started here. And the first thing I need to do, this is the first time I'm using my computer to do this, so give me a minute, okay? But I have to turn on my pen. And so bear with me here. Okay, the first problem, I need to create a frequency distribution for the following data. I'm going to use a class width of 25. So the class is going to be 25 units wide. And note that the data is sorted. That's going to help us here. On the test, it's going to be sorted for you. You see why, okay? Otherwise, I'd have to go through and sort my data or be very careful. Anyway, so how do we build a frequency distribution? Step one, we're going to start with the first class with the smallest data value, which is 10. So 10 here, all right? Next, we know that we're going to start adding 25 to the lower class limit because that's what I told you to use for your class width. So 10 and 25 is 35. All right, 35 and 25 is 60. 60 and 25 is 85, right? So there are my class limits. Now, to get my upper class limit, I start one less than the next lower class limit. So my first upper class limit is going to be 34 because it's one less. My next one is going to be 59. Another way of doing this is I add 25 to the upper class limits to get the next one. And I'm going to show you that for the very last one. For 60, one less than 85 is 84. All right. Now, to get the last one here, I can take, sorry, my pen, I got to get used to this. This is a new pen. So 84 plus 25 is equal to 9, 109. Okay. Now, hopefully that covers all of my data, and it does, so I know I have enough classes, right? See, my highest data value is 91. It fits in the upper class, right? If I needed another class, then I would have added one down here, all right? So, anyway, so next thing I'm going to do is determine the frequency. Frequency is how many items are in that particular interval, right? So, how many data values fall between 10 and 34? Well, look at this. Here's where the 34 would be, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the frequency for the first class is 9. For the second class, goes from 35 to 59. So if I look here, here's the point where separates this class from the next, right? Because 73 is not in that class, right? So 1, 2, 3, 4. 60 to 84. So 60, 84, well, that's going to be cut off right there, right? Because 91's out of that interval. There's two data values there. And then finally, 91, well, there's just one data value in that interval, right? So there are my frequencies. So the total number of pieces of data should be 9 and 4, 13, 15, 16. So I should have 16 pieces of data. You can check that, all right? Next, what is my relative frequency? Relative frequency is the proportion of data to the total amount of data. So for my first interval, that's going to be 9 divided by 16. Okay? For my second interval, 4 divided by 16. My third interval, 2 divided by 16. And then the last interval, watch what I'm going to do. For this interval here, 9 over 16 is approximately 56%, okay? 56%. My next interval, this number here, is about 25%. Well, it actually is 25%, all right? For my third one, if I take 2 and divide by 16, and I write it as a percentage and round it, it's going to be 13%, okay? So that's going to be rounded to 13%. Now, for my last interval, the total relative frequencies percentage-wise, should add up to 100%, right? You can only have 100% data. You can't have more. You really can't have less. So what I'm going to do is I'm going to add these numbers together. 6 and 5, 11, 11, 14, 6, 7, 8, 9, 94%, right? So I am missing 6% of the data. That's got to be in the very last interval. So my first interval has a relative frequency of 56%. My second one, 25%. My third one, 13%. My fourth one, 6%. All right? So that's how you build a relative frequency distribution. Once again, you can always stop this video, rewind it, and watch it over again. All right? But you should be trying the problems first and then watching the video. That's something I should have said at the very beginning. You should have reviewed your notes, then acted as though this was a test and walk yourself through this. If you're just going to watch this video and come take a test, it ain't happening. Okay? All right. I'm going to move on to problem number 2. Problem number 2, we have a histogram. It's based on a study of clinic patients' weight. So patients come in, we weigh them, right? So I've collected some data. The only thing I have to work with here is actually the histogram. I got a couple of questions to ask you. I want to know the total number of data values in the study. So how many pieces of data were in the study? Well, since this is a frequency histogram, then the heights of each rectangle is the number of pieces of data in that particular interval. So all I need to do is add up these numbers: 1, 3, 2, 5, 7, 7, 13, 6, 3, and 3. That's all I'm doing here, is I'm adding 1. Let me get my pen back in action here. I don't know why my pen quit on me. Okay, but again, I'm just trying to get used to this thing. Let me hit pause for a second. Okay, I'm back in action. All right, so I'm going to take 1 plus 3 plus 2 plus 5 plus 7 plus 7 plus 13 plus 6 plus 3 plus 3. So I'm trying to add all these numbers together, right? When I add them up, I came up with 50. So the total number of pieces of data in my study was 50. That's not too bad, right? Okay, at least I have the numbers above it. You didn't have to look to the left and try to figure out that was a 1, and that was a 3, and that was a 7. I mean, it's not that bad. All right, I want the relative frequency of the 5th class. So here's the 1st class, the 2nd class, the 3rd class, the 4th class, and here's the 5th class, right? If I want the relative frequency, it's the proportion of data in that interval, which is 7, to the total amount of data, which is 50. And if you take 7 and divide it by 50, you're going to get 14%. All right? So that's the relative frequency. And again, that was the 5th class. 1, 2, 3, 4, 5, right? Number of pieces of data, 7. Total number of pieces of data, 50. Now here's the tricky question. What is the upper class limit of the 1st class? All right, let me erase some of this stuff here. Don't need it no more. Just got to get used to my pen anyway. All right. What is the upper class limit of the 1st class? All right. These numbers here are lower class limits. All right. So this 100 is the lower class limit of the 1st class, lower class limit of the 2nd class, and etc. So if you remember, the upper class limit is going to be 1 decimal position or value less than the data. Since my data is collected in whole numbers, then 1 unit below 110 would be 109. All right? So do you understand that? It gets complicated when you work with decimal data. But basically, this here, rounding to the nearest whole number, that's why I threw that on there. So I know my data is whole numbers. So my next decimal position is the 10th position, right? But I'm not using any 10th positions, right? So I'll round up and down by 1. So reduce by 1, 109. So for example, for the second one, the upper class limit would be 119. For the third one, 129, etc. All right, moving on. we need to determine the mean, the median, the mode for the following sample data. So we have a collection of data. We need the mean, median, and mode. Well, the mean's easy. You add up your data values and you divide by the number of pieces of data you have, right? So for the mean, it's simply 1 plus 0 plus a minus 7 plus a 0 plus a 2 plus a 5 plus a 3 plus an 8 plus a negative 2, right? So that really should be in parentheses. Well, you add that up and you divide by how many pieces of data you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces of data. When you add this up, you're going to get, well, that's a negative 6, negative 4, 1, 4, 12, 10. I get 10 over 9. And if you take 10 and divide it by 9 and round it to one place, you get 1.1. The median. For the median, you have to sort your data. So we need to sort the data, right, for the median. So sort it. Minus 7, minus 2, 0, 0, 1, 2, 3, 5, and 8. That's a 5, all right? So that's the data sorted, right? Minus 7, minus 2, 0, 0, 1, 2, 3, 5, 8. Just be careful, because if you mess up one number, if you're not lucky, it's going to make a difference. All right, so I'm going to pair off my numbers. The outer two, then the next one. So I'm pairing them off. Try pairing them off. And notice what? The number in the middle is a 1. I have a number in the middle, and so that is my median. If I did not have a number in the middle, remember, you add the two numbers and then you divide by 2, right? The mode is the number that occurs the most. 0 occurs the most, so my mode is 0. All right? Now, moving on. We're going to find the variance. And then I'm probably going to stop the video and record another one, because I hate recording something and then you record the entire thing and what happens? Something crashes. You have to start over, right? So we're going to have a 2-part video here. Got it? Or maybe even 3 parts. You never know. I don't like going over 15 minutes on a video. All right. So anyway, find the variance and standard deviation for given sample data. So I'm working with sample data. That's going to come into play, right? If I want the variance, standard deviation, I'm going to build a table. But my first step is I need the mean. So I need the mean here. So when I calculate the mean, pen stopped working again. I don't know why that happened. Hold on. All right, again, I'm trying to get used to this new pen setup. All right. Anyway, if I want the variance, I need the mean. So the mean, you can show yourself, the mean is actually equal to 3. So you calculate the mean. I'm leaving that up to you. That's not hard to do. I'm going to build a table. In my table, the first column are going to be my data values. So minus 1, 0, 1, 3, and 12. So for each data value, I will create a row for that data value, right? My next column is going to be the data value minus the mean. Okay, so I take the data value minus the mean. I really don't care about the minus sign because I'm going to be squaring the next one, but just be careful. Minus 1 minus 3, minus 4. 0 minus 3, minus 3. 1 minus 3, minus 2. 3 minus 3, 0. 12 minus 3, 9. So I subtracted the mean from each data value. Got it? Now I am going to square this column. In other words, x minus the mean squared. So I'm going to square this column here. When you square negative, it's positive. 16, 9, 4, 0, 81. Now I'm going to total this column here. You add this column together, 16, 9, 4, and 81. That adds up to 110. So my column adds up to 110. So now my variance, okay, and it's for a sample, so I really should be working with S squared, is this total divided by how many pieces of data I have, 5, but since I'm working with a sample, I reduce it by 1. So it's 110 divided by 4. If you do your calculation and round it to one place, you get 27.5. So remember, the variance is the total you get here from this last column divided by how many pieces of data you have. But again, if it's a sample, you reduce it by 1. So notice I reduced it by 1 right here, right? Okay, I had to do that. Got to get used to this new setup here. All right, so I can use color. I got to keep that in mind. Anyway, that's the variance, 27.5. The standard deviation, S, is just the square root of this number. When you take the square root, you're going to get 5.2. So the standard deviation is 5.2. All right? All right, I am going to stop this video now, save it, and we're going to have a new video button that's going to be appearing somewhere right here for the next collection of problems. All right? So if you see another video button, you know that's the next one you got to press, right? All right, so we will be back.